GE 8292 Engineering Mechanics Unit 4 Dynamics of Particles. Hello students, here in this video we will see the topics about equations of motion due to gravity and the relative problems, tutorial problems 2, presented by TPGIT Vellore 2. Equation of motion due to gravity. The acceleration due to gravity is g. Hence, when the body is falls, the equations of the motion given by the equation 1, 2 and 3 are modified by substituting j in the place of a. The equation 1 and 2, 3 are v equal to u plus at and s equal to ut plus of at squared and v squared minus u squared equal to 2as. Here, instead of a, the g is substituting in gravitational equation. But when the body is moving vertically up, the acceleration due to the gravity is acting in the opposite direction. When the body is moving in vertical direction, vertical up direction, the acceleration due to gravity is acting in opposite direction. In that case, the equations are modified by the substituting minus g in place of a. The value of g is taken as 981 centimeter per second square or 9.81 meters per second square. The distance s is replaced by h. In a normal motion equation, instead of s, here replaced by height. The distance s is replaced here is height h. Hence, the equation of motion due to gravity in the downward direction and upward direction becomes. For downward direction, a equal to plus g. In particle is moving in downward direction, the gravity is positive sign. Okay, and v equal to u plus gt, and s equal to h. Here the s distance s equal to taken as height, h equal to ut plus 1 by 2 into g into t square, and v squared minus u squared equal to 2gh. For the upward direction, here a is equal to minus g. The object is moving towards opposite to the gravity force. So here gravity is taken in minus sign, minus g, and v equal to u minus gt, and h equal to ut minus 1 by 2 at square, and v square minus u square equal to minus 2gh. Okay, the next, some of the points you have to remember. The points to be remembered. First one is, if the body start from rest, the initial velocity is 0. That means u equal to 0. The body start from the initial rest position, the initial velocity should be 0. Okay, the body is comes to rest, the body is come to rest, the final velocity is 0, v equal to 0. If the body is projected vertically upward, the final velocity of the body at the highest point is 0. Okay, the final velocity at the point of highest point of the particle is 0. That means v equal to 0. If the body start moving vertically downward, the initial velocity is 0. It is u equal to 0. The acceleration due to gravity is taken positive when the body is moving vertical direction, vertical downward direction. The object is moving in downward direction. The gravity is g is taken as the positive sign. Similarly, if the body is moving vertically downward direction, the acceleration due to gravity is taken as negative sign. Okay, the object is moving in upward direction, the gravity g is taken in positive sign, and the object is moving in downward direction, vertically downward direction, sorry, upward direction, the acceleration, the gravity is taken in negative sign. Okay. The problem. This is tutorial problem. Let's see the problem now. Problem 4. An aeroplane is flying horizontally at the height of 800 meters. The bomb is released from the aeroplane when the speed of aeroplane is 600 kilometers per hour. Determine the time required for the bomb to reach the ground. Okay, and next one is the horizontal distance traveled by the bomb during the flight. Okay, that what are the data are given. The height of the aeroplane is given. The height the flight is flying at the height of 800 meters. In from the flight, the one bomb is released. Okay, at the speed of aeroplane is flying at the speed of 600 kilometers per hour. What are asking in this problem? What are the things you have to find? Determine the time required to bomb is reach the ground. Okay, at the time of flight is flying in 800-meter height and the speed is 600 kilometers per hour. At the time the bomb is released from the aeroplane, in what time is required to reach the ground? Okay, this is the first problem. And second one is the horizontal distance traveled by the bomb during the flight. Okay, during the flight. During the flying the plate, the bomb is released. Some of the distance uh, the bomb is flying, I mean moved in the horizontal direction. That we'll see in later on. The solution. The given data are the height of the aeroplane is h is 800 meter. The speed of the aeroplane is u. Initial velocity is 600 kilometer per hour. 600 the kilometer per hour is converted into meter per second. Okay, how to convert? The kilometer is converted into meter. 600 into 1000. Now meters per hour. Again, the meters per hour, hour is converted into second. Divided by 3600 or else 60 into 60. That means 600 into 1000 divided by 60 into 60. And now we will get the value of 166.67 meter per second. Or else, if you are going to similarly convert the value in kilometers hour to and meter per second, just divided by 600 divided by 3.6. Just put 3.6. Suppose we have to convert the meter per second to a kilometer per hour, just multiply by the value into 3.6. Just multiply, you will get the kilometer per hour. If you want to convert kilometer per hour to meter per second, just divide the value to the given value. Okay, uh, this is simple conversion. Okay, now the aeroplane is moving in the horizontal direction when the bomb is released. Okay, this means the velocity of the bomb, the initial velocity will be in the horizontal direction only. Okay, suddenly they release the bomb from the aeroplane. The the velocity of the bomb, the initial velocity will be in the horizontal direction only. After that, it will get come to downward direction uh, with the help of gravitational force. Okay, the velocity is equal to the in horizontal direction. The velocity of the bomb is equal to the aeroplane, obviously correct. So that is 166.67 meter per second. This is one condition, and second condition is, but the same time the bomb is attracted downward due to the gravitational force. Okay, at the same time the bomb is attracted towards the gravitational force in downward direction. Okay, the initial velocity of the bomb is in downward direction is 0. In the initial velocity of the bomb is 0 only. Okay, in last condition we already seen. The body start moving from the vertical downward. The initial velocity is 0. That means u equal to 0. This condition. Okay. Let's see. In first case, the condition is Consider the motion of the bomb in downward direction. Okay, that means the initial velocity of the downward direction u equal to 0. Okay, at the same time the bomb is throwing down in downward direction, so g equal to plus sign only here. The height of the bomb when it is released is height is 800 meter. Acceleration due to the gravity is g equal to 9.81 meter per second square. uh, Now we with this condition we have to calculate the time in at what time required to reach the ground of the bomb. Okay, the t equal to time taken by the bomb to reach the ground. Okay, using this equation h equal to u t plus 1 by 2 into g into t square. Here we have to find the t only, the small t. H we know 800 meter, and u is initial velocity equal to 0, and gravitational force is 9.81, and using this equation we have to find only t. Okay, other data we know. Okay, apply all this value in this equation and solve this resolve this equation. 800 equal to 0, initial velocity 0 into t plus 1 by 2 into 9.81 into t square. Now 0 into t is equal to 0, and simplify this equation. Now uh, half into 9.81 equal to 4.905 into t square. Okay, now take the square root. 800 divided by 9.81, sorry, 4.905. Take the square root and you will get the value of t. 12.77 second is required to reach the bomb in ground. The time required to reach the ground bomb the time required to reach the ground, the bomb is time required to reach the ground is 12.77 second. Okay, now determine the time. First you found the time. In second case, horizontal distance traveled by the bomb, distance you have to calculate. Okay, the horizontal distance traveled equal to the horizontal velocity of the bomb into time. The horizontal velocity of the bomb already we found. Here the velocity is equal to the velocity of the aeroplane. Okay, so it is 1.66 sorry 166.67 meter per second. Okay, apply this value to this equation. 166.67 into t value is now we found. Okay, 12.77 second. Now we will get the answer. The 2128.37 meter, the horizontal distance. The bomb is along with the plane in horizontal distance. The bomb is traveled at the distance of 2128.37 meter. Okay, we will find two cases. Okay. Now over second problem, problem number 5. A tower is 90-meter height. The tower is 90-meter height. The particle is dropped from the top of the tower. One particle is dropped from the top of the tower. At the same time, another particle is projected upward from the foot of the tower. At the same time, another particle, the particle 2, this is particle 1. The particle 2 is uh, projected upward from the foot of the tower. Okay, these two conditions. Both the particles meet at the height of 30 meter. The particle 1 and particle 2 meet in the meet at the point. That point height is 30 meter. In 30 meter height, the both the particles are meet. Okay. Now find the velocity. Okay, with which the second particle is projected upward. Okay, now we have to find the velocity. At what velocity we projected in the second particle, uh, the object is meeting, the both object is in meeting 30-meter height. The initial velocity of second particle we have to find here. Okay, let's see the problem. The height of the tower is 90 meter. Okay, and second, the height of the height at which the both particles meet in h1. Both particles meet in 30 meter height. Okay, distance traveled by the first particle. The first particles drop from the top. So the first particle is total height is 90. The first particle is move up to this distance. So 90 minus 30 is 600, sorry, 60 meter. The first particle is traveled in 60-meter distance, and distance traveled by the second particle. The second particle is moved to 30 meter only. S2 equal to H1. That means 30 meters for the first particle. First particle, we have find the time. At what time required to travel the first particle from the top to 30-meter distance. Okay, what times are required? Okay, in what times are required to travel the first particle from the top to 30-meter height? Okay, we have first particles moving in downward direction. So the g equal to positive sign only. The initial velocity u equal to 0. Okay, the distance s1 equal to 60 meter. 60 meter only the first particle is traveling. The acceleration due to gravity g equal to 9.81 meter per second. Let the two particles meet after the initial interval of t second. Okay, the two particles meet after the sum of the time. Okay, at the time of uh, at particular time only the two particles are meet at the point of 30 meter height. Okay, using this equation s1 equal to ut plus 1 by 2 into g into t square. Using this equation you found the t value. Okay, you know the s value. S is 60 meter and initial velocity is 0, and using this equation you will find the time. In apply all those value, initial velocity equal to 0 and g equal to 9.81 and s1 equal to 60 meter, and resolve this equation we will get the value of t is 3.497 second. At the this is the time required for meet the two particle at the height of 30 meter. Okay, 3.49 seconds are required to meet the two particles at the height of 30 meter. Okay, and second case, the for the second second particle is moving in upward direction. So we take the gravity as the minus sign. Okay, the time t equal to 3.497 second. Okay, this time is same. Because both the particles are meeting in same point. Okay, at the height of 30 meter, particle 1 is moving taking the time of 3.497, or at the same time particle 2 is also taking the time of 3.497 second only. The time is same, so the distance is 30 meter. Okay, this is moved from the bottom of the tower. Okay, acceleration is minus 9.81 meter per second because it is moving upward direction. The initial velocity with the second particle should be projected up. Okay, so now we have to find the initial velocity. At the initial velocity we have to find. Okay, and at the what velocity the object should be projected from the bottom. Okay, using this equation s2 equal to u t into half into gt square. Here s2 equal to 30 meter and u we have to find, and t equal to 3.49 second, 497 second, and g equal to 9.81 minus 9.81 meters per second, and t equal to again 3.497 second. Okay, apply all those value into this equation, say into this formula, and resolve this equation, and you will get the value of u. Okay, u equal to 25.73 meters per second. This is the initial velocity we require to throw the object to. particle or object to uh, the, this velocity is required to through the object. After that only the object 2 and 1 are meet at the height of 30 meter. Okay. Thank you, student. I hope you understand the gravitational force of the object and the two tutorial problems. If you have any doubt, just command in command box. I will give you the uh, answer and reply. Okay. Thank you. Thank you so much, and all the best.